Hi, in this video I want to share about a project I made called Pinger. So what's Pinger? It's a cross-platform client library written in C++14. It's used to send and receive ICMP echo messages, and it can be used in applications where we need to check whether a particular server is online, that is whether it's up and running. So now let's look at a demo of the library. So let's start with the demo. This is the repository containing the source code of our library. I'll go to releases here and I'll download the tar archive containing the source code. I'll copy the link address. I'll go to my terminal and fetch that tar archive using wget command. Okay, so this is the tar archive. Let's extract it. Okay, we have extracted it. Let's go to the extracted folder. I'll go to pinger folder and I'll create a build directory. I'll go to that directory and I'll run cmake dot dot. Now I'll run make. Okay, so it has generated a static library called libpinger.a and an executable file for our test program. So before running the executable, let's have a look at the test program. So this is the test program. You can see we are first including this header file pinger.hpp. Then in the main function, we are first defining a pinger config where we have to set the count and the destination address. The count represents the number of ping requests we want to send. So if we specify count as 0, then it will just send ping requests indefinitely. Then we are defining a callback function here that has the following signature. So it should accept a Boolean argument and it should return void. And this flag represents whether we are online or offline. So in this callback, like if we are online, we are printing online, otherwise we are printing offline. Now here we are creating a pinger object using pinger create function, and the create function expects the config and the callback. Then we call the start function that will basically start sending the ping requests. Then we are sleeping for 10 seconds and then we are calling stop. Now note that since we are sleeping for 10 seconds, the application may stop and exit before we have sent all the 20 requests. So that's possible. So now let's run this test program and see if it works as expected. So I'll run the executable file. So we can see that it has resolved the google.com to this particular IP address. Then it has sent 10 echo requests, and that we can see based on the sequence number, it is going from 1 to 10. And we have got the response to these requests. We can also see that our callback function was called once. We can see it has printed online over here. So that's basically the test program, and that concludes the demo. So now let's look at the design of the library. So this is a high level class diagram of the project. At the top we have pinger interface that you can use in your application. The interface requires a configuration that's provided using this pinger config structure. The library implements the interface through this pinger implementation class. This class has a socket object as a member, and this socket is basically an interface that exposes some socket related functions like send, receive, and so on. And this socket interface is then implemented for Linux and Windows through separate classes. When developing this library, I made some observations. On Windows, we cannot create a socket with protocol type as ICMP and socket type as datagram, and we must use raw sockets. Now, these raw sockets require root or administrator privileges. On Windows, you can just run the application as administrator, and if you are on Linux, then you can either run the application as root or grant the application a capability called capnet raw, and then you can run the application without full root ownership. On Windows, the receive from function is only supported for datagram sockets and not for raw sockets, so we have to use the receive function. When we call send to function, it doesn't require us to provide IPv4 header regardless of socket type. It adds it automatically unless specified using this socket option. But when we use raw sockets and we receive the packets, it requires us to read and parse the IPv4 header. In Windows, receive function continues to block even after shutdown function is called, whereas on Linux, where we use receive from function, it just throws some error. The ICMP identifier field in ICMP header doesn't need to be converted back to host order on Linux. It's already in the host order. But on Windows, we need to convert it from network to host order. This is the repository link. So if you are interested, please do check out the repository. Thank you for watching this video and hope you found it informational.